Okay, so 17, 18, F. So what we're going to be doing is solving rational equations. And this is stuff that you've done before, even back in grade 9, you just did it in a simpler form. So we're going to solve, and also we're going to state any restrictions on our variables. And state any restrictions on variables. Okay, so on Monday we did a question, something similar to this, where we found the vertical asymptotes, the horizontal asymptotes, and then there was a question where I asked you to find the intercepts. And to find the intercepts, to find the y-intercept, what we did is we set it equal to 0. And then I said, really, the only time a fraction is equal to 0 is when the numerator is equal to 0, so we just solve it. Really what I was doing is skipping some mathematics that we really should have gone through, okay? So this is a rational equation. It's a rational equation because it's a fraction. That's all it means, okay? And what number can never be in the bottom of a fraction? Because it's undefined. Yep, 0. So we can never divide by 0, okay? So what number will make this guy's denominator equal to 0? Yep. Negative 2. So what I want to do is I want to state that as a restriction because I can't divide by negative 2. Okay, and I'm going to show you why that's a restriction. Because really what I'm doing to solve this, and to solve any rational equation, is you identify the common denominator. Well, there's only one denominator. And you multiply all the terms by that common denominator. So this is really the long way of answering those intercept questions we were doing the other day. Now, what happens is x plus 2 divided by x plus 2 is 1, so that makes that denominator disappear. Again, I can do that providing x isn't equal to negative 2. Because if x is equal to negative 2, I'm dividing by 0, and I can't do that. Okay? So whenever you cross something out, state your restriction. Once you've done that, now you solve. You're left with x plus 1 on this side. On the other side, we have 0 times x plus 2. 0 times anything is 0. So the answer to your question is x is equal to negative 1, and your restriction is x cannot be equal to negative 2, because if it was equal to negative 2, then you divided by you divided by 0, which wasn't allowed. Okay? So this is essentially what you're going to do with every single rational equation. You are going to identify the common denominator, multiply every term by the common denominator, simplify, and then when you divide through, state your restriction, and then solve your equation. The only problem is the questions get a little bit harder as you go. So let's try a little bit harder one, and then they'll get progressively harder as we go on, but the concept's exactly the same. So the first question we'll do is so 4 divided by x plus 3 is equal to 2 divided by x. So there's 3 terms in this expression. The first thing you want to do is identify the lowest common denominator. So in this case, what's the lowest common denominator? Rebecca, x. So that happens to be the only common denominator, right? So we're going to multiply all the terms by x. So I'm going to go x times the first term plus x times the second term is equal to x times the third term. The whole purpose of multiplying by the common denominator is to eliminate the fraction. Okay? We can eliminate the fraction because x goes into x one time, providing x isn't equal to what value? 0. Exactly. So you have to state that to the side somewhere. Okay? So here I'm left with 4. X times 3 is x3, or we usually write it as 3x to make it look a little nicer. And on the other side, x goes into x one time, leaving you with a 2, providing x is equal to 0, but we already stated that restriction. As soon as you multiply by the common denominator, you end up with an easy equation to solve, right? So this is a linear equation. So to solve a linear equation, I bring all the x's to one side, all the numbers to the other side, and then divide to isolate my x. So the answer to the question is x is equal to negative 2 over 3. And my restriction is x cannot be equal to 0, because if it was equal to 0, I divided by 0, and I wasn't allowed to do that. Make sense? Okay. Next example. So the question's going to get a little bit harder, but the concept is exactly the same. We want to identify the common denominator and then multiply everything by that common denominator. The whole purpose of doing that is to get rid of the denominators and then state any restrictions on the variables and then solve the equation. So when I'm identifying the lowest common denominator, I'm looking for what terms that I multiply every term by so that all the denominators will cancel out. So what do you think the common denominator is for this equation? Yeah. Perfect. Okay. So you need to have an x because this guy has an x and this guy has an x. You need to have a 7 because this guy has a 7. And you need to have the term x plus 3 because that term is x plus 3. Okay, so all the terms are represented. So what I'm looking for is the smallest expression that each one of these will go into evenly. So this x plus 3 would go into that, this x would go into that, and this 7x would go into that. As soon as I identify the lowest common denominator, now I multiply all terms by that. So 7x bracket x plus 3 times the first term minus 7x x plus 3 times the second term. And that's equal to 7x times x plus 3 times the third term. So again, the reason that we chose that lowest common denominator is for this step right here. So x plus 3 goes into x plus 3 one time, so they divide through, providing x isn't equal to what number? Negative 3. You just state that over to the side. Okay. And then simplify this. So 7x times 3 is 21x. Now move over to the next one. X goes into x one time. So eliminating that x, providing x isn't equal to 0. So x can't be equal to 0. And then simplifying this, negative 7 times x plus 3 times 1 would be negative 7x minus 21. And then on the other side, 7x goes into 7x one time, again providing x isn't equal to 0, but we've already stated that restriction, so I don't have to restate it. And then simplifying that side, I get 4x plus 12, because I have to distribute that 4 inside of the bracket. Okay, so now I'm solving this linear equation, right? How do I know it's a linear equation? See?
There's no square on the x.
Right, there's no exponents on the x, right? So then whenever there's no exponents, you bring all the x's to one side, all the numbers to the other side. So 21x minus 7x minus 4x is equal to 12 plus 21. That's 10x. That's 33. X is equal to 33 over 10. That's the answer to my question. And providing x isn't equal to negative 3 or 0. Those are my restrictions. Okay. The most common mistake people make on this type of question is, one, forgetting to do the restrictions, And 2, they multiply all the denominators together, and then they would use like something like 7x squared. If you do that, you're making the question a lot harder. Okay? So always try to use the lowest common denominator. Okay, and that's very helpful in questions like this. Because if you don't use the lowest common denominator in a question like this, you could still do it, but it's going to take a lot more time and a lot more effort. Okay. So the concept's exactly the same. You have a rational equation. You want to solve your rational equation. So you identify the lowest common denominator. Okay? So the lowest common denominator has to be a term that x minus 2 goes into, x plus 4 goes into, and x squared minus 6x plus 8 goes into. Okay? So it becomes a lot easier to identify the lowest common denominator if you factor. Okay, so anything that could be factored, always factor first. Okay. So the only one that can be factored is that trinomial in the denominator over here in the third term. If I factor it, I get that. Now it's a little bit easier to see what I need to multiply by with my lowest common denominator. So my lowest common denominator, all terms have to be represented. So what do you think the lowest common denominator is? Okay. By x negative positive 4? Right. Okay. So x minus 2 takes care of that guy. X plus 4 takes care of that guy. X minus 4 takes care of that guy. And I don't have to do the x minus 2 again because I've already accounted for it over here. That's the most common mistake that people make on a test. And you will get a question like this, is they just end up multiplying by x minus 2, x plus 4, and then multiplying by this trinomial. They don't factor first, and it ends up being a huge question. You can still do it, but it's a lot of time and there's a lot of effort. Okay? So factor first, and then identify your factors, and then just use each factor once. You don't, even though x minus 2 appears twice, you don't need to use it twice. You only need to use it once. So now I'm going to multiply everything by the lowest common denominator. So x minus 2, x plus 4, x minus 4 times the first term plus x minus 2, x plus 4, x minus 4 times the second term. And that's equal to x minus 2, x plus 4, x minus 4 times the third term. And remember, the whole purpose of multiplying by the common denominator is to eliminate the denominators. So x minus 2 goes into x minus 2 one time, providing x is not equal to 2. X plus 4 goes into x plus 4 one time, providing x isn't equal to negative 4. X minus 4 goes into x minus 4, providing x isn't equal to 4. And x minus 2 goes into x minus 2, providing x is equal to 2, but we already have it. So now it's just a matter of simplifying what we've done here. So x plus 4 times x minus 4 would be x squared minus 16, and then times 3. So that's my first term. My second term, I have x minus 2 times x minus 4 times 1. So that would be x squared minus 6x plus 8. And then on the other side, I'm left with 2 times x plus 4. Distribute that through. Can I get that? Okay. So now I have to solve this equation. Is it a linear equation? Obviously not. Right, Dean? Because of the...
Because of the square.
Right. So how do you solve equations that have squares in it? When it's a linear one, you bring all the x's to one side, all the numbers to the other side, and then isolate your x. But it's a quadratic. What do you do? Lucas? Right. So you have to bring everything over to the same side and have one side equal to 0. Okay, so that's what we're going to do. I'm still going to multiply this 3 inside of here. I can't forget to do that. So I get 3x squared minus 48 plus x squared minus 6x plus 8 minus 2x minus 8 is equal to 0. Collecting my like terms, I get 4x squared minus 8x minus 48. So as long as I've done that correctly, now it's time to factor. But this is an equation. What can I do before I even start factoring to simplify things for myself? David? But remember, I only need to factor if I don't have an equation. If I have an equation, I can divide by the greatest common factor, right? So I can divide everything by 4, right? Because I don't need to factor because it's an equation. Because really what I'm doing is okay, so really what I'm doing is I'm dividing all the terms by 4. And I can do that because it's an equation, right? So then I get x squared minus 2x minus, what's that work out to be, 12? Okay, so now from here, I look for two numbers, because this is easier now. I look for two numbers that multiply to give me negative 12 and add to give me negative 2. Can't find two numbers that multiply to give me negative 12 and add to give me negative 2, so what do?
Use the quadratic formula.
Yes. So again, I chose this example because remember the quadratic formula is always in play, right? It's used to solve the roots of a quadratic whenever you can't factor. You could even use it if you can factor, right? So substituting your values in, I get 2 plus or minus 4 minus 4 times 1 times 12 all over 2, which is 2 plus or minus 4, this is negative 12, sorry, 48, which is 2 plus or minus the square root of 52 over 2. Okay, am I done? Probably not, because I'm asking you if we're done. Just like with fractions, you always simplify them. Okay. With rational expressions, you always simplify them. To simplify the square root of 52, you're looking for the biggest perfect square that'll go into 52, which is 4. So I can change 52 into the square root of 4 multiplied by the square root of 13. And that's over 2. The square root of 4 is 2, so I can change it into 2 times the square root of 13 over 2. There are 3 terms in this expression. The 2 root 13, and the 2. All of them are divisible by 2. So I can divide everything by 2. And that leaves me with 1 plus or minus the square root of 13 over 1, but I don't have to put in there over 1. So for every single rational equation, first thing you do is make sure everything's in factored form. That's the first thing you do. Once it's in factored form, identify the lowest common denominator, multiply all terms by the lowest common denominator, then divide through. Once you're dividing through, state your restrictions. Okay, if you forget your restrictions, that's worth 1 mark on the test, and that's a lot of marks to throw away. We're doing something fairly simple. And then solve your equation. If it's a linear one, solve it. Quadratic one, solve it how you would solve a quadratic. Okay, so that is it. On Monday, we will finish up the guide.